So that was the first one. And I think everyone got the answer for the first part. First part, we need to find f of EF plus 0.26. This is actually what is written over here. 0.26 electron volt above EF. It's actually above EF. So it will be EF plus 0.26. This is what we need to find at 0 Kelvin, 300 Kelvin, and 600 Kelvin. So what is the general expression for? We need to first write the general expression for f of e. For each question you can write that, because that itself will give you, if it is a problem, if you write the general expression, you will get some marks for that. So you need to write that general expression for all the questions related to Fermi level distribution. F of e is equal to 1 by 1 plus e raised to e minus ef by kt. This is the general expression for finding the probability of occupancy at an probability of occupancy of electrons at an energy level E. E in the energy level probability of occupancy on f of E in the. So here we need to find the probability of occupancy at an energy level 0.26 electron volt above EF. So we need to find f of EF plus 0.26. What is that equal to? You need to substitute EF plus 0.26 in this expression in place of E. E ke pagaram ningal EF plus 0.26 substitute cheyano. So it will be 1 by 1 plus e raised to EF plus 0.26 minus EF by KT. Correct. So initially the A part, the first part, the value of temperature is 0 Kelvin. We need to find the value at 0 Kelvin, then at 300 Kelvin. So what was the answer for this one? Already what is the answer for this one? When the value of T is equal to 0. That we know in general, like T0 on the case, we know that all the probabilities of occupancies above EF will be, what will be the answer for that? Yes, 0. Graph. So this was the graph. At 0 Kelvin, the graph looks like this. So this was our EF. So probability, that is f of E at energy levels greater than EF was 0. If it is below EF, the probability will be 1. Either case, this is applicable only in one case, that is when T is equal to 0 Kelvin. So that is the first question. At T is equal to 0 Kelvin, we need to find this value. So I think the next part also we started doing. So you can tell the answer for that. Did everyone get the answer for 300 Kelvin? F of EF plus 0.26 at 300 Kelvin. What is the value of KT? KT. KT. What is the value of that? 8.62 into 10 raised to minus 5 into 300. This is the value of K, that is a constant, Boltzmann constant. And this is your temperature, T. What is the value of, what is this value? What is the value? 8.62 into 10 raised to minus 5 into 300. ഈ വാല്യൂ മാത്രം എത്ര എന്ന് പറഞ്ഞു? Yes, 0.026 you can approximate. 0.026 electron volt will be KT value at T is equal to 300 Kelvin. So you can substitute that. So expression will become F of EF plus 0.26 at T is equal to 300 Kelvin equals 1 by 1 plus e raised to this EF plus 0.26 minus EF. So it will become 0.26 0.26 by 0.026. ന്യൂമറേറ്ററിൽ എങ്ങനെയാണെന്ന് അറിയാലോ 0.26 ആയത്, ബിക്കോസ് EF പ്ലസ് 0.26 മൈനസ് EF എന്ന് വരും അല്ലെ. E minus EF ന് പകരം EF plus 0.26 minus EF. So EF will get cancelled, and in the numerator you will be having 0.26 divided by KT value is 0.026. So it will be 1 by 1 plus E raised to 0.26 by 0.026. What will be the answer for this? What is the answer? Do with the calculator. Calculator to chede button and type the answer. No, tell the final answer. Final answer. Yes. 4.5 into 10 raised to minus 5 is the right answer. That's correct. 4.5 into 10 raised to minus 5. 4.5 into 10 raised to minus 5 is the answer. You just check whether you are getting or not. 4.5 into 10 raised to minus 5. What will be the unit of this value? F of E. What will be the unit? Will there be any unit for this? What is this actually? This is actually probability of occupancy. Is there any unit for probability? Probability unit undo? Do we? No, we are not having any unit for probability. So this answer does not have any unit because we are actually finding the probability of occupancy at 0.26 electron volt above EF. There is no unit for this answer. So this will be the answer for 0.26 electron volt above EF at 300 Kelvin. Four point three into 10 raised to minus 5. That's okay. No, 4.3. That's a difference. Approximate. That's okay. Okay, that's fine. Now the next part is we need to find the value at 600 Kelvin, right? 600 Kelvin. So what should we do for that? So I change this as $600 Kelvin. So what will be the difference? When it becomes 600 Kelvin, what will be the value of KT? KT matra change it will remain the same. What will be the value of KT at 600 Kelvin? 300 Kelvin it was 0.026. So we just need to multiply it by 2. 300 into 2 and 600. So we need to multiply that value by 2. So it will be, KT value will be point. What will be the KT value? Yes, 0.052 you can take. 0.052. Its unit will be electron volt. എങ്ങനെയാണ് ഇലക്ട്രോൺ വോൾട്ട് ആവുന്നത്? കെയുടെ യൂണിറ്റ് എന്ന് പറയുന്നത് ഇറ്റ്സ് ഇലക്ട്രോൺ വോൾട്ട് പെർ കെൽവിൻ and T temperature unit is Kelvin. If you are multiplying this, K and K will get cancelled and unit will be electron volt. So 0.052 electron volt will be the value of KT. So you can substitute that over here. Numerator, there won't be any difference. 0.26 electron volt above EF than we need to find. We have just changed the temperature value. Temperature matra change. So it will be 1 plus E raised to 0.26 divided by 0.052. Just check what is the answer. Anyone with the answer? ആദ്യം നിങ്ങൾ ആ e raised to value കണ്ടുപിടിക്കുക, then sum it with add it with 1 and then 1 by that answer. That should be the procedure. അല്ലെങ്കിൽ നിങ്ങൾക്ക് ബ്രാക്കറ്റ്സ് ഒക്കെ ഇടുമ്പോൾ തെറ്റും. You first find the value of e raised to term. ആ e raised to term മാത്രം എത്ര കണ്ടുപിടിക്കുക, add 1 to that, then divide that answer with 1. 1 by that answer will give you the final answer. Don't take much time. You are having calculators with you. Anyone? No. One second. What was one's answer? 0.26. Yes. 6.5 into 10 raised to minus 6.6, approximately 6.6 into 10 raised to minus 3 will be the answer. 6.6 into 10 raised to minus 3. അതാ ഒന്നുകൂടെ ചെയ്ത് നോക്കണം. അതാ 6.6 into 10 raised to minus 3. ഈ പറയുന്ന പ്രൊസീജിയർ തന്നെ ചെയ്താൽ മതി. ആദ്യം ആ e raised to term ഫൈൻഡ് ചെയ്യുക, then only you do the rest calculations. Otherwise you will make some mistakes in the brackets and all. Oh, okay. Okay. So the answer, I hope everyone got the answer. Answer will be 6.6. Exact answer is 6.69 into 10 raised to minus 3. This is the exact answer, and approximate answers are also fine. 6.5 into 10 raised to minus 3 is also okay. Everyone got the answer. This is an important question because this type of questions can be asked for 5 or 6 marks. You got the answers? Everyone? Okay. Okay, good. So you can do the next part of the question. You're having a next part also. 0.52 electron volt above EF. That is also to be done. Do that also. 0.52 electron volt above EF. ഏതൊക്കെ temperatures at 0 Kelvin, 300 Kelvin and 600 Kelvin. You do that also so that you will get some confidence. Point 0.52 electron volt above EF. 0.52 electron volt above EF. You need to find the value at 0 Kelvin, 300 Kelvin and 600 Kelvin. So what will be the value of what will be the value at 0 Kelvin? That is a direct question, right? F of EF plus 0.52, because in the question it is given at 0.52 electron volt above EF at T is equal to 0 Kelvin will be, what will be the answer for this? 0. Yes, answer will be 0. You need not do the calculations. You can write it directly as 0. And if okay, we can directly write the answer for that. Then f of EF plus 0.52 at T is equal to 300 Kelvin. You need to find. And earlier itself, you have found the value of KT for 300 Kelvin, 0.026. That you can use here also. Directly check. So in the question, so the answer will be like 1 by 1 plus e raised to EF plus 0.52 minus EF will be, right? EF plus 0.52 minus EF. That EF will get cancelled and you will be having 0.52. I'm not writing each step, you will understand. Hope you are getting it. 0.52 divided by KT value will be 0.026. If any doubt, you can ask that in writing this step. We are having f of EF plus 0.52. If you are substituting that with the general expression, E will be replaced by EF plus 0.52. Then minus EF is there. So EF will get cancelled and the numerator becomes 0.52. And denominator is KT that we have already found out in the previous part of the question. It is 0.026 at 300 Kelvin. So it will be 0.52 divided by 0.026 and the answer will be, what will be the answer? 1.84. If there is any mistake. If all are getting like this, okay. Final answer rather than 1.84, 10 raised to minus 9 okay, but that value is somewhat different. And if different, you just check. Yes, that is the correct answer. Check 2.06 into 10 raised to minus 9 is same as that of your answer given the text. Pranav, check it. It's correct. Yes. 10 raised to minus 9. Yes. 2.06 into 10 raised to minus 9. That's correct. There is no unit. Don't write any unit for this because this is completely a probability value. There won't be any unit for this. Pranav, okay, fine. Baki ellarum respond cheyanam. I am seeing only few responses. Everyone should respond. So as you said, the answer is 2.061 into 10 raised to minus 9. So this is the answer. You can quickly do the next part also. 600 Kelvin you can easily do that. Now you can speed up because you have done so many types of this one. You need to find f of EF plus 0.052 at f of EF plus 0.52 at T is equal to 600 Kelvin. So the answer will be, you have found out all the values except this thing, denominator. That will be 0.052. Anyone with the answer? Very good. 4.5 into 10 raised to minus 5. That's the correct answer. 4.5 into 10 raised to minus 5. Did everyone get this answer? 4.5 into 10 raised to minus 5. Okay, good going. 4.3, fine. 4.3 into 10 raised to minus 5 then that should not change. 4.3 or 4.5 is fine. Okay, fine. So you are actually now capable of doing this type of a question. If it is asked like to find the probability of occupancy at an energy level 0.52, whatever be the value of this electron volt, whatever be the value over here, value under now, I think you will be able to do that. Whether it is 0.52 or 0.26 or 0.35, whatever be the value, you will be able to find that. But now if you are asked for to find, if you are asked for finding the probability of vacancy, what will you do? That's the question. If you are asked to find the probability of vacancy at a particular energy level, what will be the step that you do? I have already mentioned this step. Suppose the question is like, you can note this. You can note this question, that's fine. Find the probability of vacancy. Find the probability of vacancy. Find the probability of vacancy of the following levels. Find the probability of vacancy of the of the following levels at 0 Kelvin, 300 Kelvin, and 600 Kelvin. That is same. At 0 Kelvin, 300 Kelvin, and 600 Kelvin. 0.2. 1 second. 0.26 electron volt below EF. This is a question. 0.26 electron volt below EF. Read the question. It is to find the probability of vacancy of the following levels. How will you find the vacancy? Now, in the previous part, we have done the, we have done it for finding the probability of occupancy. So, in order to find the probability of vacancy, what should you do? Yes, you just need to subtract that from 1. 1 minus probability will give you the answer. So, if you are asked for finding this question, in order to find the answer for this question, what is the probability of occupancy for this question? Probability of, if it was asked like probability of occupancy, you should have written like point EF, F of EF minus 0.26. It's not plus. Why? It is mentioned like 0.26 electron volt below EF. That energy level is actually below EF. It's below EF by 0.26. So that you can write it as F of EF minus 0.26. This will give you the probability of occupancy, but you are not asked for that. This will give you the probability of occupancy. In order to find the probability of vacancy, you need to subtract this from 1. 1 minus F of EF minus 0.26 will give you the probability of vacancy. This alone will give you the probability of occupancy. When you subtract this answer from 1, you will get the probability of vacancy. Can anyone tell the answer quickly? At 0 Kelvin, what will be the answer at 0 Kelvin? Can anyone tell this quickly? Final answer, 1 minus F of EF minus 0.26. Very sorry to say that this answer is wrong. 1 minus F of EF minus 0.26 at 0 Kelvin. Remember the graph at 0 Kelvin. What is the value of F of EF minus 0.26? What is the probability at an energy level below EF? EF in the energy level, what is the probability? What is F of E? I am asking the final answer. I need the final answer. Yes, it is 0. I hope you remember the graph. It was like this, right? E graph 0 Kelvin matra applicable on square shaped graph. This T is equal to 0 Kelvin. This is applicable for this one only. EF, and here you have 1, and this is actually F of E, and this is actually your energy level. So EF is this point, below EF is these points, right? Here you are given a point which is below EF at 0 Kelvin. So below EF, what is the value of F of E? Its value is 1. Whatever be the value of energy level below EF, the probability value F of E will be 1. So this part will be 1. You are subtracting 1 from 1 and you will get 0. Is that clear? Is that clear? Okay, fine. You do the next part. What is the probability of vacancy at 300 Kelvin? Do that. What is the probability of vacancy at 300 Kelvin? Don't make mistakes. It's asked like probability of vacancy at 300 Kelvin. Either you can simplify that, and after that you can do. See, it can be written as 1 minus, what is f of EF minus 0.26? It will be 1 by 1 plus e raised to EF minus 0.26 minus EF by KT. So it will be again equal to 1 minus 1 by 1 plus e raised to minus 0.26 by KT value at T is equal to 300 Kelvin. We know that value. KT value at T is equal to 300 Kelvin is 0.026. So if you take LCM and write, then you will get it like 1 plus e raised to minus 0.26 by 0.026 minus 1. I am taking LCM by 1 plus e raised to minus 0.26 by 0.0226. So this 1 will get cancelled and the rest you can find. Any way you can do this. You can either find the one part and subtract it from 1. Please check the answer. ഒന്നുകൂടെ നോക്കി. Yes. 4.5 into 10 raised to minus 5 is the right answer. (4.5 into 10 raised to minus 5 is the right answer. What about others? Anugrah. Dhyan. Anas. Okay, those who have done this, you can do the next part at 600 Kelvin. so that that question will be completed. At 600 Kelvin also you can find that. 1 minus f of EF minus 0.26 at T is equal to 600 Kelvin. You can complete that also. We can discuss that tomorrow. No issues with that. If you're having any doubts, you can discuss tomorrow. Try to do that by yourself. Final part at 600 Kelvin. You can do that. No. Yes. 6.6 into 10 raised to minus 3 is correct. Another 6.63693 into 10 raised to minus 3 is the correct answer. Mistakes അങ്ങനെ വരരുത്. കിട്ടിയോ? Oh, 6.7 is also fine. Everyone got the answer? Nikhil, കിട്ടിയോ? Okay. Okay, fine. So you just note one question that we will do in the next class. അടുത്ത class ചെയ്യും, but you just note that question and think about that. I will tell the question. Show that probability of a state delta E. Show that the probability of a state. Show that the probability of a state delta E above EF. Probability of a state delta E above EF is filled. Probability of a state delta E above EF is filled equals probability that a state delta E below EF is empty. Is filled equals probability that a state delta E below EF is empty. Equals probability that a state delta E below EF is empty. This is a question. I will just give a hint for that. You can try to do. You are asked, you need to prove something. What is that you need to prove? probability of a state delta E above EF is filled. What is the probability of being filled? Occupancy, probability of occupancy of a state delta E above EF. You will write it as F of EF plus delta E. You know that. Delta E in the energy state above EF is filled. We need to show that is equal to equals probability that a state delta E below EF is empty. That is vacancy. This has to be, or we need to prove that this value, that is probability of occupancy at an energy level delta E above EF, is equal to probability of vacancy, that is F of EF minus delta E. You need to prove this. That is a question, and I think this was asked in some of the question papers. You need to prove this. That is a question. That you can easily substitute this value for in your general expression, and you can find the answers. That you will do in the next class. And now you can take that.